Hello everyone. Today we are going to talk about AC circuits. In these AC circuits, mainly today we are going to discuss about R circuit, C circuit, nothing but capacitance circuit, inductance circuit, then resistor combination with inductance circuit, resistance combination with capacitance circuit, resistance combination with inductor and capacitor circuit. This combination we are going to analyze with AC circuits. What we are going to learn? Today we are going to learn the voltage and current analysis for resistance circuit, inductance circuit, capacitance circuit. How we are going to analyze? With the help of phasor diagrams. Phasor diagrams gives exact relationship between voltage and current waveforms in terms of angles. So today we are going to discuss about the phasor relationships, voltage current relationships, and we are going to talk about impedance also. What do you mean by impedance? Nothing but the resistance offered by the AC circuit. So everything we are going to see in this class. So shall we go ahead? Yes. The first thing we are going to talk about is AC circuit with resistor combination. AC circuit with resistor combination. What is the circuit diagram? What is the voltage current relationship? Nothing but phasor diagram. Everything we are going to get with the help of the mathematical expressions. So first let me draw the circuit diagram. This is AC supply, which is nothing but VAC. This is resistor, and current flowing through resistor is instantaneous current I of t, and you can make a loop also. That current you can make a loop also, because we are having only single loop. Now how we are going to get voltage and current analysis? Simply by applying KVL. KVL loop for this circuit, if you apply, that's it. Okay. The standard form that we are going to take is VAC equals to Vm sin omega. This is the standard representation of AC input. You can make it omega t plus pi. That pi is nothing but phase difference between voltage and current. Okay. Now I took standard input. VAC equals to Vm is nothing but peak input voltage and sin omega t. Okay. This input voltage I am applying for resistive circuit. How we are going to make KVL loop? That we will see. Supply voltage. What do you mean by KVL? Kirchhoff's voltage law. Nothing but the algebraic sum of voltages around any closed loop is always 0. Now what is the algebraic sum of voltages in this circuit, which is nothing but VAC, current is entering here positive, leaving is negative, minus VR equal to 0, because there is no voltage drop is happening in this circuit. VAC equals to VR. VAC equals to VR. Now I want to talk about what is VAC. VAC is nothing but Vm sin omega t. Now what is the voltage drop across the resistor? The voltage drop across the resistor is current flowing through it into resistance value. So finally I'll get current flowing through the resistor at any instant of time. So what is I of t equals to? Which is equals to Vm by R into sin omega t. I got the voltage and finally I got the current. What is this Vm by R? Which is nothing but peak value of the current. That peak value of the current we are going to represent as Im sin omega t. That I am going to represent as I of t equals to Im sin omega. Now what is the input supply that we have given for resistive circuit? V of t equals to, which is nothing but Vm sin omega. If you clearly observe these two functions, there is no phase difference at all. That means what you understood, for resistive circuit there is no phase difference. What is the phase difference between voltage and current for resistive circuit? It will be 0, but amplitudes will be changed. So if I want to plot the phasor diagram, voltage and current are in phase with each other. Voltage and current are in phase with each other. In phase with each other. Now I want to talk about the phasor relationship between voltage and current with diagram. Now the supply voltage I will draw. This is the general representation of sinusoidal waveform. The peak voltage is Vm, this is V of t, and this is 0, this is pi, and then 2 pi. Otherwise you can represent this is t by 2 and then t also. Now when you clearly observe, this is the standard representation of the voltage waveform. Now I want to plot the current waveform also. Current waveform, always the peak value depends upon the resistance. If the resistance value is very low, then current value is very high. If the resistance value is very high, the current value is very low. So obviously the current value will be less. I want to plot the current also. How I can plot the current? That I will indicate it clearly. This is in phase. In phase na both initial and final angular positions exactly same, but the peak values will be different. The peak values will be different. Therefore, what is the phase difference? There is no phase difference. The two waveforms are not separated with any angle at initial and final stage. That's why there is no phase difference between voltage and current for resistive circuit. Then what is the phase difference between voltage and current for resistive circuit? It will be 0. It will be 0. That means voltage and current, they are in phase with each other. This is the phasor representation. Suppose sometimes they will ask what is the vector form, vector representation also. You can write, this is one voltage vector. In the direction only, the current vector also will be there. The voltage vector and current vector both are in phase with each other. Both are in phase with each other. So that's the analysis of AC circuit with resistive. So what do you mean by resistor? Already you know. Resistor means resist plus ions. It will stop the flow of electrons. But for AC circuit, the voltage and current relationship are in phase with each other. There is nothing is happening when you keep resistance. Okay. Now we are going to analyze the AC circuit with inductance and capacitance. In competitive exams, they are going to ask only one thing: what is the phase difference between voltage and current for pure resistive circuit? Pure resistive, there is no internal drop will happen. So the word pure mentioned, there is no internal resistance will be there. Nothing but internal drop won't happen. The pure word will be used for inductance and capacitance. Sometimes they will use for resistance also. At that time, you should not tell any drop is happening in the component. No. No drop is happening. Okay. Now, we are going to analyze the AC circuit with inductance. What do you mean by inductance? If I am taking one straight conductor carrying some current, surrounding it, what it influences? It influences field. What is that field? Magnetic field. It will produce certain flux around this conductor. If you want to use that flux, is this flux is sufficient? No. For that purpose, what I will do is, I will make twists and turns like this. Why I need to do like this? because everywhere the current direction is changing, everywhere the current direction is changing. If the current direction is changing, then flux associated with also it will change. So it will produce the bunch of flux like this. Outside it will produce the bunch of flux like this. This cumulative flux only we are going to consider. This cumulative flux only I want. Instead of using single conductor, if I use the same conductor with multiple twist and turn, what happens? It will produce large amount of flux. That large amount of flux only I want. For that purpose only, what I am going to use? I am going to use inductor. This is the main idea about inductance. So how this flux will be produced? That will be defined with the help of Faraday's law of electromagnetic induction. There is little basics are there that already you have learned in the previous classes, that I am not going to touch. Okay. Now, AC circuit with inductance. AC circuit with inductance. Now I am going to discuss about AC circuit with inductance. Very simple analysis. Take input AC circuit with inductance and then close the loop. Here also the input supply will be VAC and current flowing here will be I of t, instantaneous current. Inductance entering is positive, leaving is negative. You can make a loop also. I want to talk about the voltage and current analysis here. Here also what we need to apply? We need to apply the KVL analysis because it's a loop. If it is a multiple branches, then definitely what we need to apply? We need to apply KCL. Oh, now this is a loop. I want to apply KVL. Algebraic sum of voltages around this closed loop is 0. Then what will come? VAC equals to VL. Supply voltage equals to the voltage across the inductance. What is supply voltage? What is the standard form? Vm sin omega. Now what is voltage across inductance? According to Faraday's law of electromagnetic induction, the voltage across inductance which VL equal to L di by. What is voltage across inductance? VL equal to L di by dt. Here, what is the resistance offered by the inductor circuit? That one more term is there after this derivation. I'll tell. The input supply is Vm sin omega t, which is equals to L di by dt. From this one, I want to know what is the current. If I find the current, then only I can establish the relationship between voltage and current. What is the phase difference between voltage and current? That I can be able to explain clearly. Okay. Now di by dt equals to Vm by L sin omega t. Now I want to eliminate this differentiation. Then what is the differentiation opposite process, which will be integration? Okay, that we are going to talk. Now integrate on both sides. You can write integrate on both sides. If you want to integrate on both sides, integration of di by dt equals to this dt I will send that side. Otherwise, we'll keep it here also, no issue. Integration of di equal to integration of Vm by L sin omega t. Now, right side, this peak voltage and inductance value, it is constant only. That I will take it outside. What is integration of di, which is equal to I? You can mention I of t also, no issue, because that is instantaneous value of current, which is equals to This Vm by L is a constant, take it outside. Then what is integration of sin omega t? Which will be minus cos omega t. I am integrating with respect to t. Then what is one more term will come? If I integrate omega t, what will come? By omega. By what is the term will come? Omega. This omega I will keep it like this. So what is the next step? I equals to, we got Vm by minus Vm by omega L into cos omega. If I want to find the phase difference between current and voltage, I just want to convert in same trigonometric functions. If I convert in same trigonometric function, it will be useful. I can define the things easily. And one more thing, here current is negative now. Current is negative, meaning is current is lagging. What is this negative meaning? In inductor, current is lagging. Current is lagging. Lagging behind what? Lagging behind voltage. Current is lagging behind voltage. Okay, that we are going to represent with perfect mathematical equation. Okay. I equals to Vm by omega L. I want minus cos omega t. I want minus cos omega t. How I can write that? We will see. Minus, I will keep it like this. Sine of, what is pi by 2 minus omega t? Sine 90 minus theta, which will be cos omega t. Is it clear or not? Cos omega t, I have written sine 90 minus omega t. Absolutely no doubt in this one. Okay. If I introduce what is sine of minus theta, which is minus sine theta. Now I want to introduce this minus inside. Then what will come? I equals to Vm by omega L sine of what will come? Omega t minus pi by 2. What we got finally? I equals to Vm by omega L sine omega t minus pi by 2. Clearly, if you see this one, this is the standard representation. I equal to Im sine omega t plus or minus pi. This plus indicates leading, minus indicates lagging. Then what is this pi? Pi indicates phase difference between voltage and current. Here, one more thing I want to talk about it. What is this omega L? That only we are going to call as XL, inductive reactance. What is I equals to Vm by XL? What we are having? Sine of omega t minus pi by 2. What is this Vm by XL that we are going to write further? I equals to Im sine omega t minus pi by 2. Then what is V equals to supply? V equals to Vm sine omega t. So finally I got voltage and current equations for inductor. From this one only I am going to judge what is the phase difference between voltage and current. With this help only I am going to plot the phasor diagram. Okay. How we are going to plot, how we are going to do all these things, we will see. Now if we clearly observe, what is the phase difference between voltage and current? 90 degree. So current is lagging by voltage by how much? 90 degree. This is very important. This is pure. In pure inductor, current lagging by voltage by how much? 90. Current lagging by voltage by how much? 90 degree. This is very important. Okay. Now I want to plot the phasor diagram. Phasor diagram. I want to talk about phasor diagram for AC circuit with inductance. How we are going to talk, that we will see with the help of mathematical equation only. First, I am taking the voltage is reference V of t, nothing but otherwise V input supply, VAC equals to Vm sin omega t. The vector form I am plotting. Then after that the phasor form will plot. Okay. Current is lagging by voltage. Current is lagging by voltage by how much? 90. Suppose simply if it is lagging, by some angle, this you can draw like this. Simply if it is lagging, so you can make representation voltage reference, but current is lagging by some angle, that you can represent with it. But if it is exactly by 90 degree, that you can represent perfectly with vector diagram with this one. Okay. Now I want to talk about in sinusoidal waveforms. Okay. So first of all, I am going to plot the voltage V of t. Okay. This is voltage and this is time. V of t with respect to this is t by 2, this is t. Now the current I want to talk about it. How current will be? Current is lagging by 90 degree. Current is lagging by 90 degree. After voltage only current will start. Don't try to plot behind. That means it is leading. You need to plot current is lagging by how much? Lagging by 90 degree. Exactly 90 degree you make it. Okay. Then you plot it. You maintain. This is only we call phasor difference. The angular difference between voltage and current, that we are going to represent with the help of phasor diagram, that we have indicated clearly here. I hope this is clear.